Good morning. Today we are going to discuss about human-computer interaction subject. So the basic things: human and computer. Human, computer. Human is a different rate of sensings are available, like vision, hearing, sensing, touching, and then identifying. So different perspectives we are going to see for that in human, but in system, these are the signals we are going to receive in the system. So we are using the biometric systems. Similarly, different multimodal systems we are going to use to find out how the data will be transforming in human as well as computer. So those things we are going to discuss in now the sessions. So previously, different authors and developers are finding that different solutions are given here. So how we are going to transforming the data, how it is possible, those things we are going to discuss now. The first thing is functions of human computer interactions. So here we are specifying four representations. One is input, second one is output, third one is memory, and then reasoning and problem solving specifications. So first thing is we are going to discuss here in human basic. So we are easily identify what type of data are available. So we can easily able to identify in different modes. That is visualization of data, finding of data, and then sensing of data. So these three ways we are easily able to identify. The next thing is analyzing and then fine tuning the process. We are going to apply some techniques we are going to use. So then only we are going to find out the data. So here we are going to discuss the first three we are going to discuss. In this context here, different authors I said no. In 1983, Codd, Moran and Newell described model for human processor, which simplified the view of human processing. It is involving the human as well as computer. So in the previous generations we are not introduced that. So in the 1960s, 1970s, only we are having input and output signals only in manually. So that is punch cards data only we are giving. After that time, 70s started. So we are going to give the input in the keyboard. So then it will develop in the 1983. Interactions will be happened in the human as well as the computer. How it is possible? How it will be involved? So initially the low level process only we are making. So after that the high level process we are going to, nowadays we are using. In input and output channels here, the mainly the three things I said no, senses, major senses: sighting, hearing, touch, taste and smell. So here sighting, that is a viewing. So where the data, what type of data we are going to view. So our eye is captured for that, like a sensing cameras, like hearing. Our data will be heard, voice recognition. Here we are using human. Here or mic, like that. Mic is the data will be transforming analog signals. The analog signal will be transferred into digitalization format. Then it will stored in a database. Then it will transform into some way. So that process is hearing process, and then touch. So that is the input of different process, like that. Touching is biometric data sensing. So we are using touch screen. So our security specifications we are making pattern recognition. Other informations are specified in touch. And then taste and smell is differ in human computer. So machine is not performing that, but we are given that input of value, some set of data, that it will be nowadays robotics will be performing that tasting and smelling. So the first three things we are going to discuss now. Okay, so however vision, hearing and touch are essential. Similarly, these are all the number of efforts including lens, fingers, eyes, head and vocal systems are we are using. Here in the computer, fingers play a primary role, like we are making in typing, or we are using a keyboard, mouse and other devices also we are using joystick. Okay, so different devices we are using to give an input. Okay, like writing the process. Okay, similarly, sensing informations here, hearing. So what data we are going to receive in your here, like speakers are using. We are using speakers. So the information we receive, that it will be converted into our statements. That is like our data. So voice recognition we are given. So immediately the what kind of data, what kind of sentence we are spoke, so that it will be transformed in a sentence formation, like a Word, Excel, whatever formations we are required, so that it will be converted. Nowadays we are using different languages like Tamil, Hindi, Urdu, Telugu, whatever the languages we are using. So what we are speaking, that it will be converted automatically. So translator we are using, the human computer interactions will happen. So how it has happened, how the process is we are going to convert. So those things we are going to one by one we are going to discuss now. Like a vision, sensing. The sensing part is like a lens we are using, our lens. See our short and long vision is we have. So the distance of the data we are going to receive, so the specific limits we are using. Okay, see here the limitations are human vision is highly complex activity with a range of physical and perceptual limitations. See here we are specifying. Human eye is here we are specifying. See, human eye is cornea and tandem and lenses we have. The lenses breadth may be expand, then the vision will be reduced. So here we need to understand both stages, as both influence what can and can't be perceived visually by human being, which in turn directly affect the way the design of system. So here in human eye as an example, the data will be captured, then that it will be transmitting to the nerves, that then we are imaginated that it will be, we are going to draw or picturizations, whatever coloring, whatever the activities we are going to do. So eye is a physical receptor, and then go on to consider the process involved in the basic vision. So our eye is a basic vision to convert what kind of images we are seeing, so that it will be transformed. See here the next one is vision, then memory, that is the storage. See here it allows to repeat an action, to use language and use new information received by our senses. See, we are understanding what kind of data we are received, like a touch sensing. Who is touch for us? Namma yaar touch panika. So we are going to identify for that. So here, so what type of data we are observed, like our climate. Climate may be today, maybe winter season. The next month or very next month maybe come different type of seasons will come. So every month the seasons may be changed. Before rainy season, autumn season will come. So one by one the thing will come, but our skin will sense to what kind of data we are observed, that it will be transferred to our nerves, the nerve will be sent to our brain, then it will transform. These things are happen to our human body, so that it will be transformed. So we are going to visualize the data. So the data will be stored in our memory. See here, the three type of memory here we are going to use in our human body. The data will be transforming, and then this data will be translated to our system. Okay, so here first three type of memory: sensory buffer, short-term memory, and long-term memory. Okay, see here, the sensory memory. The sensory memory is always every human having. So sensory memory is who is in front of us. The recognition of our visual as well as human skin and hearing. So everything is sensory activity is available. So the data will be immediately indicate to our human brain. So then, so who is in front of us? The sensor will immediately reflect for us. So short-term memory in back or memory in the lower, that it will be indicated. So the data will not store in long duration. Sensory memory just who in front of us, so immediately recognize and then leave it. So the data will transfer. If it is needed, it will take up, or otherwise it will leave that. But in short-term memory, some set of process will execute up to the value, up to the data is there. And then after that, the data will be leave. The process is over, then the data will be leave, like a run. So if the process is over, if it is not, no need to save, so in our memory, so automatically the data and the process, everything will be destroyed. But in long-term memory, it will be stored in a memory, internal memory. Our human brain, we are never forget for that. So the data will be stored in long-term memory, like we are storing in our internal disk, that it will be stored permanently. We are not raised for that data. So here we are using three type of memory. One is sensory buffer, short term and long term. Three type of memory. So sensory is receiving the data. What kind of data around us? Okay, immediately receive us. Like a cobra, we are go in front of cobra. So immediately the cobra will sense the human is in front of us. Or some frog, if it is made in front of cobra, so immediately sense for the cobra in front of frog is there. So who is in front of, immediately the sensing level up to the 1 meter, 2 meter, 3 meter, the eye visualization, absorption will be received, like every animal, like that. Human is also observing, sensory memory is available, immediately identifying that who, what kind of data we are going to receive, who is calling, who is notifying for us. So immediately a sensory memory will be absorbed. Someone is calling, someone is clap, someone is give some eye contact. So those things are absorbed in sensory memory. So that is first one, but sensory buffer as we are going to use. Short term has that signal will be transferred that particular duration, the minimum duration 10 to 15 minutes, up to the data will be stored in short term memory. After that it will leave. But in long term memory it's not like that. It will be stored in a permanently whenever we need. So wherever we need, we use it in that long term data. See here, the sensory memory, iconic, ecopic, haptic. So attention. So that iconic. So who is visible? Who is identifying? So what kind of data we are going to observe? So those things are available in sensory memory buffer, that it will be transferred in short-term memory or working memory. that is functioning. So what type of data we are going to process, that it will be stored in short-term memory. We are going to see in a movie. So that particular duration only the movie scenes will be playing in our memory, short-term memory. After that, we leave in the theater, that it will be destroyed. So just in fun for that particular duration only. After that, it will be automatically erased. But in long-term memory, that it will be again and again, repeatedly call itself. That is, we are specified that it is we are stored in long-term memory. See here, that structure is here we are given here. The sensory memory acts as a buffer. Sensory memory is like a similar to temporary storage. So temporary storage, but it is some specific durations only will be stored. Okay. So these memories are constantly overwritten by new informations. So if we are going to see for that particular duration, so that particular duration only the memory or the data will be available. After that, new thing we are going to see. So we are traveling in a by train or some bus. So immediately our data will be refreshed. Immediately our data will be refreshed. Why? Because so we are not recollect. All the data will be continuously we are watching in the bus or train or wherever we go. So the data will be stored in a temporary memory only. That is a sensory buffer. The data will be stored. Which place we are going to remember or recollect, that it will be go for short-term memory. That short-term memory data will be go for a long-term memory. So then next. Short-term memory is working as act as a scratch pad. Just we are moving that next slides we are going to use it now. So like a temporary recall of information. So buffer it is available, but it is not permanent. So the data will be available there in the particular duration of the time only. So chances are that you will have done this calculation in stages. So different sizes we are here indicated. So it is performed like that. So 5 into 6, 30, then 30 into 6, then after that 2 into 3, 6, it is 70, 3 into 70, like that. We are going to perform different perspective, we are going to calculate it. Long-term memory, it is intended for the long-term storage of the information. Information is placed there from working memory toward the rehearsal. So long-term memory is a permanent memory. So it is stored whenever we need. Immediately we recollect for all the information, that it will immediately come to our visualization process. So we are recollect that these things are happen that particular duration, these things are happen this particular duration, this logic is we are going to use for that particular place. So immediately it will come to our screening. So that is a long-term memory process. The semantic structure that just now I said no. Semantic memory is derived from in our episodic memory, such as we can learn new facts or concepts from our experience. Semantic memory is structured, so the data will be stored. So this process we have done annually. So those things available in long-term memory. So this is the structure of long-term as well as short-term memory structure. See here, architecture loop, and then central executive, and then auditory imaging systems, and then visual speed sketchpad. So these are all the things simultaneously bidirectionally connected with central executive. So auditory loop, and then visual spatial sketchpad, auditory image system. So these things are short-term memory, that is buffer will be available. But in long-term memory, how the value will be stored. So we are specifying animal. The animal is indicated as a dog, and the dog is how the sound will be available, and then other aspects, eagle, how the eagle will colors and other activities. So those things we are recollect for that. Okay, so here a long-term memory is a hierarchy structure. What are the process in that particular object is have? So that thing is we are going to discuss. In the next one is reasoning and problem solving. There are here we are taken for reason. So why we are going to find out that object? What is the need for that project? So here we are going to take up the solving particular object. Problem is we have that reason. So we are going to find out that what type of problem is we have. So we are solving for that. So there are number of different type of reasoning. First one is deductive reasoning, inductive reasoning, abductive reasoning. So three type of reasonings we have in everyday our life, but there are different significant ways to identify. So these are all the reason we are going to solve. Okay, so next one by one we are going to see that reasonings. First one, deductive reasoning. Deductive reasoning derives logically necessary conclusion from the given premises. See here the example, if it is Friday, then she will go to work. It is Friday, therefore she will go to work. So here first one and second one, see, if it is Friday, then she will go to the work. Okay, if it is Friday, then she will go to work. The second specification, if it is Friday, therefore she will go to work. See, then, therefore, see the difference is for reasoning here we are specifying. If the Friday, then the person will go to the work. Therefore, concluded, the end of the day, that's why therefore it is indicated. Therefore, she will go to work. See, next, it is important to note that this is the logical conclusion from the premises. It does not necessarily have to correspond to our notation as truth. For example, here, if it is raining, then the ground is dry. If it is raining, then the ground is dry. It is raining, therefore the ground is dry. See this, listen, see this. Raining means automatically the rain is falling that particular duration. Okay, if it has happened, how it is possible the ground is dry? How it is possible the ground is dry? It is not possible. It is not possible because the raining. Now the time is raining. The ground is not dry. So automatically the ground is going to flood for the particular duration. Okay, so that's the reason here. If it is raining, then the ground is dry. It is a perfectly valid deduction, even though if it conflicts with our knowledge what is true in the world. Deductive reasoning therefore often is misapplied here. So here, if it is Friday, how you conclude if it is Friday? How you conclude if it is Friday? So maybe today is a Monday, so today is a Wednesday, today is a Thursday. How you are going to conclude for that? So here we are specifying reasoning, deductive reasoning. So you are going to apply for that knowledge. So if it is not acceptable or maybe misplaced, you are going to use for that misapplied for the particular deductive reasoning spaces. Next, some people are babies, some babies are crying. Some people are babies, and then some babies are crying. These some people are babies. That means here the people are grown. The people are grown, but their activity is like babies. Their activity is like babies. Some babies are crying. Some babies are crying. That means normal babies will cry, but grown people are not there always crying. Grown people are crying because they are not understanding they are capable. They are not known for their fact. So that the reason this thing has happened. So these are all the deductive reasoning fact for here we are specified. It is at this point that truth and validity clash. The human deduction is poorest. Our explanation for this that people bring their whole knowledge into the reasoning. There is a good reason for this. It allows us to take shortcuts which make this dialogue and interaction people between informative and efficient. So that's why I am telling. See here, we are not specific particular statement. So previous statement and the next statement and the next statement. This statement also indicated for that like that. So the statement we are going to specify means that it will be deductive reason is available, it is correct, the statement is correct, so we are go for that. If it is not, so we are analyzing for that statement, then we are go for the next one. Okay. Inductive reasoning. Generalizing from cases we have to see information about cases we have seen not for that. So here every elephant we have ever seen has a trunk. We infer that all elephants have trunk. Of course, this inference unreliable and can't be proved to be true. All the elephants have trunk. All the elephants have trunk. How we say some of the elephant can't have a trunk. Some misstatement is we are going to see. It can be proved to be false. If it is, we are going to specify, we are going to say for that word, all the elephant by default, all the elephant having a trunk. By default, born and brought up, they having trunk. Without trunk, they can't survive. Without trunk, they can't survive in that area. That means in that environment. So immediately that will be fall down. So we can disprove the inference simply by producing an elephant without trunk. So how it is possible? So we are going to give a false statement. We can easily able to these statements are by default we are going to reject it. Okay, so that is we can never prove it is true, because no matter how many elephants with trunk we have seen or not known to exist, the next need to see many trunkless. We are not seen anywhere trunkless in the elephant. We are seen everywhere, all the elephants seen only with the trunk. Okay, so this thing has happened. Next, the best way we can do is gather evidence to support our inductive inference. So, if we are going to give the statement, inductive reasoning, so we find different perspective. We are going to justify for our inductive reasoning. We are going to collect for the data. Then only we are going to give the better solution for that. Next, common example for this. Let us check the A and 4. However, this uses only positive evidence. In fact, the test the truth of the statement, we need to check negative evidence. If we can't find a chord which has an odd number on one side and vowel on the other, we have disproved the statement. We must therefore check A and 7. Here, only the vowels only you are going to 7. Only you are going to check. So, E is a vowel. Remaining 4 and 7 and K are not vowels. That it is, we are going to specify numeric as well as a constant of the value. Only the thing is, here we have only E, only we have a vowels. Remaining integer value as well as constant value we have. That is what. Here that thing is only we are going to specify. Let us check E and 4. Only the positive evidence we have, but positive evidence how we are going to represent? See here, E is a vowels and the remaining is integer values. That only we are going to justify for that. Next, abductive reasoning. The third type of reasoning is abductive reasoning. From fact to the action or state to the caused it. Fact to the action. Fact to the action. So what we are going to specify, if the vowel, we are going to say vowel, it automatically come to the fact. What are the things in vowel? A, E, I, O is A, E, I, O, E. That it is fact. That it is come to that. So here, or it may be cause for that. If it is not there, so causing of error will be arise from there. So for example, here we are given, we know that Sam always drives too fast when she has been drinking. If we see Sam driving too fast, we may infer that she has been drinking. Of course, this is too unreliable, since there may be another reason why she is driving fast. She may have been called to an emergency. So here some specific statement here we are specified. First statement, Sam always drive too fast when she has been drinking. And she has been drinking. So when she is drinking, at the time Sam's drive too fast. First category. Second category, Sam driving too fast, we may infer that she has been drinking. Someone is interrupted, then Sam may drive too fast. The third category, here the first two statement, some other unreliable, the statement is not matched. First one is, who is she is drinking, that the reason he may faster. The second reason, someone is interrupted, she is not drinking, someone is interrupted, is driving too fast. So that here this is too unreliable, since there may be another reason. So it is controversy is there. This two statement having some controversy. Someone is interrupted, the specific person is interrupted. See here, abductive reasoning is action or a state. Action or a state. So here action is someone is intrude. Someone is intrudes. That is the reason the person is driving fast. Someone is interrupted, the action is fast. So this thing is happened. It is, in spite of its unreliability, it is clear that people do interfere explanation in this way and hold on to them until they have evidence to support an alternative theory or explanation. So here the objective reasoning is someone's state is here going to play, that it may cause some different actions may be happen. See here the three reasonings that we have. The three reasonings that we are going to perform some rules, the design rules. So we modulate for that. So we are using to solve this problems. Okay. So designing maximum usability, the goal of interaction design, principles usability, general understanding, standards and guidelines, direction for design, design pattern, capture and reuse design knowledge. So the design rules having design for maximum usability, principle of usability, standard and guidelines, design patterns. Okay, so the four perspectives we are going to discuss now. Principles. First one, abstract design rule, low authority, high generality. Principle. First one, principles. First one, abstract design rule, low authority, high generality. Standard, specific design rule, high authority, limited application. High authority, limited application. Guidelines, lower authority, more general applications. See here in the principle specifying low as well as high. In the standard, high, guidelines is low. The limitation is variations from different perspective. Principle of support usability. Principle of support usability. Principle to support usability. Learnability. Here, the easy with which new users can begin effective interaction and achieve maximal performance. Flexibility. Multiplicity of the way the user and system exchange information. Robustness. The level of support provided the user in determine successful achievement and assessment of goal-directed behavior. Predictability and synthesizability, determining the effect of future actions based on past interaction history, operation visibility, synthesizability, assessing the effect of past actions, immediate versus eventually honesty. Predictability and synthesizability in learnability, determining the effect of future action based on past interaction history, operational visibility. Synthesizability here, assessing the effect of past action, immediate versus eventually honesty. Familiarity, generalizability, consistency. Familiarity, the knowledge specifications we are going to specify where and in how it is possible. Generalizability, extending the specific interaction of knowledge to the new situation or specific areas. So consistency, likeness in input-output behavior arising from different situation or specific task. Principle of flexibility, dialect initiative, multi-threading, task migratability, substitutivity, and customizability. Principle of robustness, observability, recoverability, responsiveness, and task conformance. Standards. Here, in the national and international bodies ensure compliance by large community of designers. Standards like a sound and underlying theory and slowly changing the technology. Hardware and standards more common than software, high authority and low level of details. ISO 9241 define usability as effectiveness, efficiency and satisfaction with which user accomplished task. Guidelines more suggestive and general, and understanding justification for guidelines aids and resolving conflict. Guidelines and applicable during later life cycle activities, applicable early life cycle activities. Golden rules for curiosity. First one, broad brush design rule. Useful checklist for good design, better design for using these than using nothing. Different collections. Nelson's 10 curiostic available. Golden rules available. Norman 7 principle available. Synergen 8 golden rule principle is available. Synergen 8 golden rule principle. First one, strive for consistency. Enable frequent users to use shortcuts. Offer informative feedback, design dialogues to yield closure, offer error prevention and simple error handling, permit easy reversal of action, support internal locus of control, reduce short-term memory load. Norman 7 principle, use both knowledge in the world and knowledge in the head, simplify the structure of task, make things visible, bridge the gulf of execution and evaluation, get the mapping rights, exploit the power of constraint, both natural and artificial, design for the errors, then all else fails, standardize everything. It's a design patterns, an approach to reuse knowledge about successful design solution originated in architectural Alexander. A pattern is an invariant solution to a recurrent problem within a specified context. Example, two sides of every room, go back to a safe place. So these are all the examples of design patterns. GMOS. GMOS is goals, operators, methods, selections. What the user wants to achieve, basic action to perform, Decomposition of goal into sub-goals or operators, means of choosing between completing methods. So these are the expansion of GNOs. Goals is specifying like an algorithm. So what task you are going to execute, operator, and then standards you are going to, methods you are going to follow. So then we will get the output. So here specifying that goal, use menu, move, pull down, click. These are all the functions you are going to perform, apply for the logic. So we are getting the results. Cognitive complex theory. See, these are the things we are going to discuss. So, I think we are discuss about interaction about the different perspective, and also GMOS specifications also we are going to discuss, and then learnability, predictability, these things also we are discussed. So it will come for that in the part C as well as part B questions will come to our university examinations. Okay, thank you.